So we have done with a routing part. So before routing, we discussed about network fundamentals and WAN technologies. And the network fundamentals, lot of things we have discussed about the day one of session, introduction to networking and network components and NIC, media, networking devices, and IPv4 and IPv6 address logics completely we have discussed, and subnetting we have discussed. The TCP IP layers and the OSI layers we have discussed clearly. And introduction to routers, router internal components, external components, all about routers we have discussed, and router configuration. And then WAN technologies, like laser line and broadband services, and WAN connectivity, and WAN topologies, configuration, DC, DT interfaces, point-to-point protocol, SDLC protocol, and WAN interface configuration and troubleshooting, these things we have discussed. And introduction to IP routing, routing conditions and routing types, which is static and dynamic, and static routing, and dynamic routing types, classless, classful, and dynamic routing. Past few days we are discussing about dynamic routing protocols like RIP, OSPF, and we have compared the last session with our three protocols, which is RIP, OSPF, and EAGRP. So successfully we have done the main core routing part. So from today, let me start with LAN technologies, switching. In LAN technologies, enter the LAN technologies, the most popular physical layer LAN technology is Ethernet. So a small introduction of Ethernet. So technology originated by University of Hawaii. Later, Xerox Corporation has been adopted. The Ethernet is the most popular physical layer LAN technologies. So as per IEEE standards, Ethernet 802.3 IEEE standards, and Ethernet speed we know 10 Mbps. And types of Ethernets are Ethernet, fast Ethernet. So Ethernet is one of LAN technology. See, if any technology if any technology comes under LAN code is 802. In 802, we have different type of technologies. One of the most popular is .3. So .3 is what? Ethernet. And Ethernet types, we have different type of Ethernet. Like Ethernet is IEEE standards is 802.3. Next, fast Ethernet is also Ethernet. So Ethernet means 802.3. But speed is the difference, right? So speed for Ethernet is 10 Mbps. And fast Ethernet speed is 100 Mbps. Then how we can define IEEE standard is 802.3U for fast Ethernet. Gigabit Ethernet 802.3 speed is 1000 Mbps or 1 Gbps. To define the speed, 3 A, B and Z we use. For 10 gigabit Ethernet 802.3 AE is 10,000 Mbps or 10 Gbps. These are IEEE standards. So fast Ethernet IEEE standard is 802.3U has been established for need higher transmission speed purpose, and gigabit Ethernet is what developed for faster communication networks with applications like a multimedia, voice over IP address like this. 802.3 AB and 802.3 Z. Z for optical fiber. 1000 Mbps or 1 Gbps. And 10 gig. So 10 gig is entirely designed for optical fiber connections. These all are different type of technologies in Ethernet. And in entry, the LAN technology is the most the most popular device is switch. So we are going to discuss about now switch and its functions. So switch is a layer 2 device, network data link layer device. The router is layer 3 device, switch is layer 2 device. Router works with a IP address, like based upon source IP, destination IP, router will packet switch and packet forward. like router will make the communication based upon the IP address. Now switch. So switch forward the traffic based upon the MAC address. So switch maintains a MAC table. In MAC table, it has source MAC and destination MAC. So let me see now how exactly switch will functioning. This is a switch and 24 port switch I have used here. Now for port number 1, let's consider how one device is connected. Port number 2 device and port number 3, port number 4, port number 5, port number 6. Right. Switch maintains MAC table. So MAC table contains port number and MAC address. Every device has a unique MAC address. Let's say first PC MAC address is A1, A2, B1, B2, C1, C2. Now, to enable communication between these devices, we have to assign IP address. So IP address will be there for every PC. First PC IP address is 10.10, 10.20, 10.30, 10.40. Like have assigned IP addresses to all computers. Now, device will start exchanging data. Let's see how switch functioning now. So here scenario is first user is trying to communicate with sixth user. So first user is a source device and sixth is a destination device. You know, by default, your MAC table is empty. There's no information. I mean, which PC, which port number is connected, so that information is not available. Okay. Now user 1 is trying to reach user 6. Frame is being going to generate here. That is source IP address. Source IP address is 10.10. Destination IP address is 10.60. Now what is source MAC address? Source MAC address is A1. And what is destination MAC address? Destination MAC address is a C2 that we know by seeing the diagram. So by seeing the diagram, we can say destination MAC is C2. But what your real time, like how we can come to know destination is a C2? So don't know. Even your MAC table is also is not available when where C2 is been connected. So C2 on which port number is connected in MAC table also there is not there, right? So when destination is not available in the MAC table, in switch we have one layer 2 protocol which is ARP will come in the picture. So what ARP is doing is it's going to send the request with all FF which is broadcast MAC address. So last MAC address. No, all 255, 255, 255 is a broadcast IP address. So all FF is a broadcast MAC address. So broadcast message is being generated here. So which is taking care about this broadcast MAC address is ARP protocol. So what ARP is doing is address resolution protocol is sending a request, ARP request. Why? So PC1 need 10.60 computer MAC address. So IP is available, but IP address, your switch will not understand that. So switch can forward the traffic based upon the MAC address. So MAC address source is available, destination is unknown. So now we need a 10.60 computer MAC address, right? So for that, it's sending a request, ARP request. So this frame is being generated in 10.10 computer, right? So now this frame will come to port number 1. You know what switch will do? So first action of switch is learning source MAC address. From where exactly traffic is being generated. If traffic is coming from B2, so B2 is being updated. If traffic is coming from A2, so A2 is updated. So source learning source MAC address. So first switch first action is learning source MAC address. Now what is the source MAC address? A1. Now traffic is coming from which port number? Port number 1. So port number 1, A1 is updated. So after learning source MAC address, now it look for destination MAC address. Now what is the destination MAC address? The destination MAC address is a all FF broadcast. So this frame is going to sending to now all 24 ports in the switch. Because of unknown, destination is not available in MAC table, right? Now what ARB is doing is, so broadcasting. So broadcast means sending a traffic to all devices. Sending to all devices. So port number 2, port number 3, like all 24 ports is being broadcast. Now port number 2 is received. You know what port number 2 will do? It'll check the destination IP address. So your destination is 10.60, but my PC IP is 10.20. I'm not your destination. I'm not your destination because of your destination is 10.60. But my PC is 10.20. I'm not your destination. It'll drop it. So A2 is dropping. Your PC3 is dropping. PC4 is dropping. PC5 is dropping. Now PC6 will give you reply. Yes, I am your destination. My computer IP is 10.60. Okay, your destination is 10.60. I am your destination. What do you need? Yes, I am requesting you. I need a MAC address. Oh, do you need my MAC address? Yes, I'll give the reply. Now this PC is giving reply. What is source IP now? Now source IP is 10.60. Destination IP is 10.10. And what is source MAC address now? Source MAC address A2. Destination MAC address ARP reply. ARP reply to which MAC address? A1. So this frame is being generated in PC6. Now this packet will come to port number 6. Now what switch will do? What is the first action of switch? Learning source MAC address. Now what is source MAC address? Source MAC address is C2, so it's updating the MAC table. Source MAC address C2, and it's learning from which port number? Port number 6. Okay. After learning source MAC address, now it look for destination MAC address. What is the destination MAC address? Destination MAC address is a ARP reply. ARP reply to which MAC address? A1. Now A1 information is available in the MAC table. Now switch knows how to reach A1. So how to reach A1? Port number 1. So do you need again broadcast here now? No need, because of your MAC table is updated, right? So now what switch is doing is, okay, my destination is A1 now. It is come to port number 1. So directly we'll send to port number 1. So this communication is unicast. So switch can support for broadcast will do and unicast will do. So as per your understanding, so when switches will do broadcast and when switches will do unicast? Any answers?
If the port and MAC information is available in our table, then it is the unicast. If it is not available, then it is a broadcast.
Where available, where not available?
In the table.
Which table?
MAC table.
MAC table, yes.
MAC address table.
Yes.
Yeah. So if destination device, a destination can be any device. So destination your printer, destination your server, destination your PC, whatever device you are trying to reach. So that destination device MAC address, if it is available in the MAC table, so based upon the MAC table information, switches will do unicast communication. If destination MAC is not available in MAC table, then ARP will come in the picture, broadcast will happen. So the broadcast happened to the entire switch, the whole 24. Your switch is 24 ports is broadcast. Your switch is a 48 ports is the broadcast. So the whole switch is, so complete switch is a a single broadcast domain. So switch is a single broadcast domain. It's clear? Yeah. So next point is now port number 2, port number 3, port number 4, port number 5. So port number 2 MAC address is A2, port number 3 MAC address is B1, port number 4 MAC address is B2 and C1. Now all 6 computers MAC address information is updated in MAC table. Now what type of communication happens in this switch? Unicast communication or broadcast communication?
Unicast.
Why?
Unicast.
All the information is available.
Yes, now all MAC information is available in the MAC table. So now unicast communication, right? Okay. After some time, your PC3, so this computer is not in use. It's just idle. From PC3, there is no request is not generating. No request. Then what your switch will do? So switch is going to hold the information. B1, port number 3 information is going to hold up to 300 seconds. So up to 300 seconds, if there is no request from the PC3, then automatically your B1 port number 3 is being flushed in the MAC table. Aging time. So switch MAC table aging time is 300 seconds. So from that PC, there is no request. If it's just idle, then after 300 seconds, this MAC information is being flushed. So port number 3, B1 is being flushed from the MAC table. Okay, now B1 is not there in the MAC table. Now A1 want to reach B1, then what type of communication happens?
Broadcast.
Broadcast. So because of the PC3, the broadcast happened to how many ports?
Ports.
All 24 ports. So in your network, any one of the device is not responding for 300 seconds. I mean, if no request from 300 seconds, again, broadcast will be happen in your network. So this is how switch will be functioning. And switch can support for unicast communication. Switch can support for unicast and broadcast, and switch ports can support full duplex communication, half duplex communication also. And switch each port speed is a fixed bandwidth. Bandwidth is fixed. So switch ports are 100 Mbps ports, then always 100 Mbps ports. Let's see how to configure the switch. Switch configuration. This is switch behavior. Now, these type of switches are two types of switches. Switches are basically two types. One is manageable and unmanageable. What is a manageable switch? The name itself is telling is it manageable. We can manage. What we can manage? Like one device is generating the broadcast going to all 24 ports. So all remaining all the 24 ports unwantedly receiving the broadcast. Moreover, it is not secured also. If for switch 1, if switch 2 is connected, then the broadcast will come to switch 2 also. First 2, 3 is connected. The broadcast will come to switch 3 also. Like how many switches are connected, all switches are being affected. So these broadcasts we can minimize in manageable switch. This broadcast we can manage. In which type of switches? Manageable switch. And we can control the network access. If have any resource in the LAN, like we have a FTP server. So this FTP server resource, Like which users want to utilize it. Like PC user want to utilize or PC3. So remaining first three PCs should not use. Then we can control them. Like you want to allow to use next three PCs, yes, you can allow them. So you have internet in your network. Like selected users have to use internet. So that we can configure. So we can control the user's traffic and we can minimize the broadcast in LAN and we can provide security in the LAN. We can configure the switch. We can assign IP address. We can enable telnet functionality. So user traffic management is possible in manageable switch. So the name itself is telling us what manageable. So we can manage everything. We can manage the broadcast. We can manage the resources controlling, and we can configure the switch, whatever your requirement. So configurations can be made. Unmanageable switch. So we cannot do anything in unmanageable switch. No configurations, no manage. It just you can purchase and plug in and power in, plug and play type. Just give the power connection and play. That's it. Then how we can find out which is the manageable and which is unmanageable switch? So every manageable switches has a console port. If there is a console port, it's a manageable switch. No console port, unmanageable switch. On manageable switch, IP address can be assigned and configurations can be made. It has a console port. Unmanageable switch, configurations cannot be made. IP address cannot be assigned. There is no console port. There's a major difference between manageable switch and unmanageable switch. In the real time, we used to work with the manageable switches. Home networks, the net cafes, there we use what? Unmanageable switches actually. Okay. See, in switches, Cisco is designed different type of switch roles. The campus LAN, the building network, Cisco uses three terms to describe role of the switch. The campus design, which is access layer switch, distribution layer switch, core layer switch. In the routers, we have branch router, network edge router, ISP router. Similarly, in switches, access layer, distribution layer, core layer. So generally, switch will come under which layer? No ASI. Switch is a layer 2, right? So all end user devices, it's all your end devices are connected to access layer switches.
Distribution layer.
Access layer switches are connected to distribution layer. Distribution is connected to core layer. This is a hierarchy design. Now access layer switches are layer 2 switches. Means layer 2 functioning. Layer 2 functioning means it maintains the MAC table based upon the source MAC with destination MAC. The traffic is being forwarded. So layer 2 devices cannot understand the IP address. It's just will work with what? Based upon the MAC address. Layer 2 addresses. The layer 2 device. But distribution layer switch. So distribution layer switch is a layer 3 switches. Layer 3 switch we call. Means it's a layer 2 and layer 3 both. What is a layer 3? Layer 3 is a router. Network layer, right? So means this distribution layer switch can understand IP address. So distribution layer switch can understand routing protocols. Layer 2, layer 3 protocols. Layer 3 protocols are what? Routing protocol, routed protocol, static routing, dynamic routing. These things we can implement in distribution layer also. Now, if you have a distribution layer switch in your company, then router is not required because of distribution layer is doing the routing job also. So distribution layer is a layer 2 and layer 3, both is doing actually. The core layer we call multi-layer switch. Means layer 2, layer 3, layer 4, TCP, UDP functioning, routing protocol, routed protocol. It's very high-end device actually. Core layer switch, multi-layer switch we call it. Then how can you find out which is access layer, which is a distribution layer? Means series, model numbers. Like 1900, 2950, 2960 is a access layer switches. Distribution layer switches are 3550, 3560. These are all distribution layer switch. The core layer switch is 6500. These are.
Balu, what is Nexus switches?
Yeah, layer 3.
Okay.
Next is also one of the part of the Cisco layer 3 devices.
So Balu, like, how can we identify like which switches are belongs to which layer? Because I know like 5000 series are the distribution and 9000 series are the core layer. So like, is there any identity how to find those or?
Yeah, based upon the series, we can find out which is the layer 2 and layer 3.
Okay.
So let's see how to configure it. Initial configuration of switch. You know how to configure router? If you know how to configure router, then you also know about how to configure switch. Because of both works with the Cisco IOS, router and switch. Cisco IOS, Internet Work Operating System. Even switch also works with what? IOS. Switch has a console port. Router has a console port. And connect device console port to PC. And you can use emulation softwares like a PuTTY. Switch also console cable to device and use PuTTY software. You can access it. In router, we have router user mode, router privilege mode, router global configuration mode. The same in switch also. Switch user mode, switch privilege mode, switch global configuration mode. So what are the commands we have used? Show commands. All the show commands are the same. Like user to privilege to global config. Almost like switch and router configuration is the same. Two 2960. I'm using one switch. Let me connect some devices. 1, 2, 3, 4, 5, 6, 7. 7 devices I'm connecting to. First PC, port number 1, port number 2, port number 3, port number 4, port number 5, port number 6, and port number 7. Now let me assign, let me configure switch, CLI. Yeah. Switch user mode. Enable, show version, iOS version is 12.2, and Cisco 2960, model number, 24 fast Ethernet ports is there, and plus 2 gigabit ports, total 26 ports. Ports are 26. Like, config mode, same. Host name, switch A. How configured host name is switch A. And how we can check MAC table is show MAC address hyphen table. By default, MAC table is empty, right? MAC table is empty. Now let me assign IP address to computers. If you assign IP address, request is being generated. So first computer IP address. Example, I'm using 20.1. So when I have assigned first computer IP address, then your MAC table is updated. So on MAC, port number 1, like this. So let me assign all computers MAC addresses. 92168.20.2. The next computer, 20.3, 20.4, 20.5, 6, and 7. Now, if you check MAC table, show MAC table, show MAC address table. Now, all port numbers has been updated. MAC address. Now, what type of communication happens in this switch? Unicast communication or broadcast communication? If PC1 want to communicate with the PC2. So unicast because of MAC table is updated, right? Now, without any request is generating, if you wait for 300 seconds, your MAC table will become again empty. Well, let me check that. So like this, we can assign the host name and MAC table verification. Switch port settings. Like we can configure the ports. Example, interface. I'm using any one of the ports. Port number 80/8. So port number 8 is a fast Ethernet port, right? So fast Ethernet port means how much speed it can support? 100 Mbps. Fast Ethernet port number 8, right? 100 Mbps. Now we can set the speed, port speed. So just we can write speed space 10. Now port number 8 can support only 10 Mbps. So forcefully we made port number 8 is a 10 Mbps only now. Actually it is a 100 Mbps, but we have said 10. If use speed is 100, now port number 8 is 100 Mbps. Or you can configure auto negotiate. So port number 8 can support up to 10 to 100 Mbps. Can be any speed. So like we can set the speed. Not
Hello,
only
what
speed. Yeah.
hello? What if we give more than 100, it will take or
No. Up to 100.
okay.
Yes. Now we can set duplex also. Duplex half. If we use this command. Now port number 8 can support only half duplex communication. Either you can send, either you can receive. If you configure duplex is full, then port number 8 can support only full duplex communication. If I use duplex is auto, then port number 8 can support half duplex also, full duplex also both. Depends upon other device. Other device, what type of communication is initiating. If it's initiating half duplex, then switch port number 8 will adjust half duplex. If his other device is sending a full duplex communication, port number 8 can adjust full duplex because of we have enabled what? Duplex is auto, speed is auto. So based upon other end device, switch port number 8 can adjust automatically. So like this, we can manage port speed and the duplex communication. Okay. Right. So like we can set the port speed. In real time, you know how we can come to know in which device, which port number, which device is being connected. Say you are a new trainee, so you don't know on which port number which device is connected, right? So what your senior administrators will do means they can write description command to the ports. Example, port number 1, this PC is a workstation A is connected. Let me make you one new diagram. So port number 1, you have connected device. This is workstation A, and port number 2 device workstation B. B is connected. Let's say port number 3, your internet router, ISP router is connected. For port number 4, maybe your internal server, like file server, FTP server is connected here. And port number 24, it is connected to switch B, means uplink is connected to switch B. But you don't know where workstation A is connected, B is connected, right? So now what your senior engineers will do means they'll write the description like this. For port number 1, interface fast Ethernet 0/1, port number 1, description, space, workstation. So after description, you can write anything actually. Here, I'm writing workstation A, exit. Now for port number 2, workstation B. Port number 3. What is the description? Port number 3. On port number 3, your ISP router is connected, right? Yeah, port number 3, ISP router. For port number 4, what is the port number 4 description? So description, FTP server.
FTP.
Yeah. And where your uplink port? Port number 24. Description is uplink is connected. Means other switch is connected. Right? Rafi, can you hear me? Yes, okay. So like this, we can write the description based upon your devices, where your devices are connected. And if you save the configuration part by using WR, now any engineer, maybe junior engineers also has been logging. If we show running configuration command, they can come to know clearly here. So here description is a fast Ethernet port number 1, workstation A is connected. Okay, maybe workstation A is connected 1. Like inside the switch, we are labeling part. So generally outside the cables we used to label, right? So similarly inside the switch, we are doing the writing the description. And which port, what is the connected? So by seeing the description, we can understand, okay, port number 3, ISP router is connected. Port number 4, FTP server. And port number 24 is a uplink, means other switch is connected like this. Okay. Now, how we can assign IP address to switch? Or how we can assign IP address to router? First tell me how to assign IP address to router. Generally we use command is a for router LAN port FE00. No, default is shut down. Then you can use interface FE0/0 and IP space, address space, IP address and subnet mask. No shutdown, right? And we'll do exit. This is a configuration for switch, for router. Now what about switch? How can I assign IP address to switch?
Yeah, same thing.
Ports
Interface
are
and
port number 1, port number 2, port number 3, port number 4, 5. We have 24 ports. Then what is the command?
Port number and IP
Interface,
address.
fast
Port
Ethernet
number.
0/. Which port number? Port number 1? 1. Okay, port number 1. And IP space, address space, IP address. So we have assigned IP address to only port number 1. What about port number 2? If you assign IP address to port number 1, then you can log in only port number 1. Then what about port number 2? Port number 3. How many ports in the switch? 24 ports. Means 24 IP
24.
address we have to assign.
No,
If it's 48 port switch, then
I
48
think
ports. Then how?
1 to 24. Interface fast Ethernet 0/1 to 24.
No, not like that actually. So switch is LAN. Switch is nothing but LAN, and switch inside it maintains one more LAN called VLAN, virtual LAN. Virtual switch. Inside the switch have one more switch. VLAN default is 1. VLAN 1. In VLAN 1, port number 1, port number 2, 3, 4, 5, like all 24 ports, the member of VLAN 1, the part of VLAN 1, all 24 ports, the part of VLAN 1. So if we assign IP address to VLAN 1, then we can access all 24 ports. So VLAN 1 IP address is a switch IP address. How we can assign IP address to switch means interface VLAN 1 IP address. Like this. Subnet mask, like we assign IP address. I'll show you the commands. Show VLAN brief. If is the command show VLAN brief, all ports 1, 2, 3, like all 24 ports in the part of default VLAN 1. So that VLAN 1 is a management VLAN. So that VLAN 1 is the administrative VLAN. So we are going to assign IP address to that VLAN. Like interface VLAN 1 IP address 68 20 dot something 50 255 255 255.0. No shutdown. So like this, we are going to assign IP address to switch. VLAN 1 IP is a switch IP address. So VLAN 1 change state to a protocol is up. It's clear? Like this, we can configure initially remaining passwords. The console password, enable password, same like a router. Telnet password, VDY, these things we can configure. Okay. But again, back to switch functioning. So how switch functions? Broadcast and unicast. When switch will do broadcast?
Balu, not
Yeah,
the
please.
Balu.
Yes.
Can you show me the half duplex and full duplex, how it works?
Data exchange can possible, like data from PCs to PCs. Normally, data exchange can possible in 3 ways. It is simplex communication, half duplex communication, and full duplex communication. So there are 3 methods to data exchange: simplex, half duplex, full duplex. What is simplex communication? So simplex means one-way communication, only one way. Like from TV stations to the TV, we'll receive the signals to TV. From TV can generate the signals to a TV station? No. So you just receive the signals and we'll give the output. We can watch it and we can communicate. Same like a radio stations, radio station to radio. Just receiving the signals only one way. That is simplex communication. But computers, computer to computer, can you send data? Yes. If you're sending data, your PC can receive it. If you are sending it, you can receive it, right? So we can send and we can receive. But sending and receiving same time is not possible. So simultaneously, data transmission and receiving is not possible in half duplex communication. So if enable half duplex in between the PCs, either we can send or either we can receive. Like a walkie-talkies, the best example, well-known example of half duplex is either you can transmission, either you can receive. It's a half duplex communication. Then how full duplex communication works? Simultaneously, you are sending and you are receiving also. Both is possible in full duplex. So in the switch ports, if you configure half, then from that port you can only send the traffic or you can receive the traffic. If your switch port is a full duplex, the same time data is receiving, you can send also without any collisions. In half duplex, when you are sending the data, if someone is receiving, then your data has been collapsed. Collision happens. Data is being dropped. But in full duplex, no collision. So smoothly, data transmission receiving is possible. So this is a simplex, half duplex, and full duplex communication. Clear, Madhu?
Yeah, Balu. Thank you.
Yes. So when switches will do broadcast and when switches will do unicast?
Are getting the MAC table, switches will do broadcast.
Okay.
After table is getted, then they will do unicast.
No.
Whole table is
1 port to 1 port to get the data is called unicast.
No, when switch will do unicast? When can do broadcast? So example here, it is a switch. Switch 2, switch 3, 3 switches is it? Each one is a 24-port switch. In switch 1, in first switch, computer 1, computer 2, 3 computers are connected. 1, 2, 3 ports. By default, MAC table is what? Empty. So first user is trying to communicate with the second user. What type of communication happens now? Unicast or broadcast?
Broadcast.
Broadcast. So broadcast to how many ports? All 24 ports. So switch is a one broadcast domain, single broadcast domain. Now what if I connect a switch link between switch 1 to switch 2 have connected across cable? Same example, first computer and second computer is trying to communicate, MAC table is empty. Now broadcast happened to first 24 ports and port number 24, the same broadcast packet sent to port number 2. When switch to port number 24. Now what switch to port number 24 will do? A broadcast to again all 24 ports. So means now broadcast size is 48 ports. So actually physically they are two switches, but logically both are belongs to one domain, comes under one broadcast domain. Now, if I connect it to switch 2 to switch 3 link, now 3 switches are interconnected. The same scenario, first switch user 1, first switch user 2 communicating. That broadcast packet come to the port number switch 1 all ports, switch 2 all ports, switch 3 all ports now. So 72 ports are got affected the broadcast now. So if we increase the LAN size, we are increasing broadcast domain size. Now you can understand the real time, like if it's a university building, like there will be number of departments, number of sections, and number of blocks. So all means there will be hundreds of switches will be available. So all are interconnected. Or if you take example of some many pharma companies, laboratories, there are different hospitals, very multinational hospitals. So different flows, different switches and equipments. So any one of the device will generate the broadcast is going to affect it, enter the building, enter the university, like enter the 100 switches. So actually, first two devices are trying to communicate, but broadcast happen to all 72 ports. So unwantedly traffic is coming to other devices, is going to making impact in your network. And moreover, it is not secured also. You know why? Because what the two pieces are trying to communicate, that information broadcast coming to all the ports, like any one of the user is a hacker here, they can be monitor what they're exchanging. Not secured. Problem. So how to solve this solution says, let me use only one switch example. Now port number 1, just a minute. Yeah, here port number 1, we have one device connected. Port number 2, device. Port number 3, device. Port number 5, port number 6, port number 7. Let's consider first 3 devices are belongs to sales department. The next 3 devices are belongs to HR department. And port number 4, port number 4 device, consider it's a admin computer. Now all ports, like all 24 ports, the part of which VLAN by default, VLAN 1. How many ports is the part of VLAN 1? All 24 ports. Like port number 1, port number 2, 3, 4, 5, 6, 7, 8, 9. All 24 ports in the part of VLAN 1. So VLAN 1 is a single broadcast domain. So VLAN means which is a one domain, right? Yeah. Now you can consider sales user and sales user is trying to communicate. PC1 sales computer communicating with the PC2 sales computer. Data traffic is being generated. So what if MAC table is empty? What type of communication happens? Broadcast. So that broadcast happens to how many ports?
24.
Now broadcast happened to port number 2, port number 3, port number 4 means admin is receiving And port number 567 means HR department is receiving. So actually sales are communicating, but unwantedly traffic is coming to HR department and the rest of all ports also. If the switch is connected to another switch, switch 2 also affected. Connected to other switch, 3 is also affected. Connected to 4. Now, actually sales are communicating, but traffic, your broadcast is going to all the switches. Problem, not secured, unwantedly broadcast. It's going to making your network is slow down. So what we'll do means to overcome this type of issues, this VLAN 1, so single broadcast domain, we need to divide into multiple broadcast domains. So VLAN 1 need to divide into multiple VLANs. So VLAN 1 is a single broadcast domain. So dividing single broadcast domain into multiple broadcast domains is VLAN. So VLANs are used to minimize the broadcast domain in the network. We are minimizing broadcast domain. How? Divides a single broadcast domain into multiple broadcast domains, or divides a single VLAN into multiple VLANs. So VLANs group interfaces to create a small broadcast domain. It provides layer 2 security. Like department wise, section wise, project wise, we can divide. For example, department wise, sales department. Now 1, 2, 3 ports have configured for 1, 2, 3 ports is a VLAN number 10. So default is 1. We can start creating from VLAN 2, VLAN 3, VLAN 4, up to 1001 VLANs we can create. So I'm using my example is VLAN number 10 for sales. Like within a switch, virtually or partition. Like inside the switch, we are creating a virtual switches, small broadcast domains. For 5, 6, 7 ports. Port number 5, port number 6, 7 ports are created VLAN number 20. So once you segregate your network into VLANs, now if sales PC is trying to communicate sales PC, now broadcast happens within the VLAN only. Means broadcast happens to only the 2 ports, port number 2 and port number 3 only. Now broadcast is not come to other VLAN because of it is now one domain. So even now here switch 2 is connected, 3 is connected, 4 is connected, 100 switches is connected. Even broadcast is happen only 1, 2, 3 ports. But before VLANs, remaining entire all 100 switches got affected. But after creating VLANs, now your broadcast size is minimum. Here only 1, 2, 3 ports are broadcast. So completely your broadcast has been minimized, and sales devices, sales department securely they can communicate because of this traffic is not going to other departments. So they are securely communicated. So two major advantages of by creating VLANs is we can minimize the broadcast and can provide switch level security, means layer 2 security. Okay. So by default, all ports of the switch are in VLAN 1. By default, are in VLAN 1.
If we are creating VLANs, we have to assign port numbers also.
Yes, we need to implement the port numbers. It's just VLANs is creating. After creating VLANs, we need to implement the port numbers. 1, 2, 3 comes under VLAN 10. 5, 6, 7, you need to implement on VLAN 20 because of all the ports in the part of VLAN 1, right?
Yeah.
So 1, 2, 3 ports we need to implement from VLAN 1 to VLAN 10. So 5, 6, 7 ports.
Rest of all interfaces we need to shut them.
No, rest of all the ports belongs to default VLAN 1.
Oh, no need to do anything.
No need to shut down.
Oh, okay.
All ports are in active state only. Yes.
By default, how many ports? If, for example, when switch has 48 ports, so all 48 ports should be in VLAN 1 only. by default?
Yes. This is the point.
Okay.
By default, all ports of the switch are in VLAN 1. A switch can be 24 ports or it can be 48 ports. All are in default VLAN 1. Now, what is the switch IP have assigned? Have assigned switch IP address is 192.168.20.50, right? 20.50 is the switch IP address. The for sales department have 192.168 20.0 network IP address, means 20.1, 20.2, 20.3. In the HR department computers, I'm using 192.168.30.0. See, switch IP address is 20.50, sales department is 20.0, HR department is 30.0. Now, out of two departments, sales and HR, which department users can log into switch, can able to access the switch? Sales or HR?
Sales.
Sales. Why?
Sales.
Why?
Because both are on the same network.
Because of switch IP address and sales department in the same network, right?
Yes, Paulo.
Yeah. So can we able to log in from HR department to switch?
No,
Yes. No. Why? Because it's in a different
different
network, right?
network.
Yeah. Even from sales also, we cannot able to log into switch. From sales department also, we cannot able to log into switch. You know why?
Network ID.
Network ID, not network ID. Let's example 20.1 have used, 20.2 have used, whatever. That is not a logic actually. So logic is 20.50 IP address we have assigned to which VLAN?
One,
VLAN 1. Sales department users on which VLAN?
VLAN 10.
So different VLANs, how they can access? So we have assigned IP address to VLAN 1, but sales department in VLAN 10, HR department is VLAN 20. So you forget about the networks here. You just focus on the VLANs and the switching. If your PC is a part of VLAN 1, then only you can log into switch. If your PC is a part of any other VLANs, not possible even if you are the same network also. Okay. So now port number 4, this PC is a part of which VLAN?
VLAN 1.
VLAN 1. So from this PC we can log in. If you are maintaining the 20. Network IP address. Now rest of the ports, port number 8, port number 9, rest of the all remaining all ports the part of what? Default VLAN 1. So that you want to manage the switch, your PC should be in the VLAN 1. VLAN 1 is known as administrative VLAN or local VLAN, management VLAN. Like this. The VLANs can be created from 2, 3, 4 up to 1001 VLANs we can create. So VLAN is going to segregate our network into based upon the department wise. We can divide a single broadcast domain into multiple broadcast domains to minimize the broadcast and to provide layer 2 security. It's clear? Yeah, let's show the practical now. How to create the VLANs and how to implement.
Balu, doubt here. So
Yes.
when you're configuring the VLAN to the switch, the same VLAN has to be configured in devices also, or it is not required?
We are configuring VLANs in piece switches only now, not PCs.
Okay. The communication will be happen even
Yes.
there is no
Communication
VLAN.
happens within the sales department. They can communicate each other, all sales department. And HR department, they can communicate each other. But the traffic communication will not happen sales to HR because of both are different broadcast domains.
Okay, then VLAN it is in within the switch only.
Yes. We'll discuss for the next switch also. Switch B also will see now. In this diagram, as per the same diagram, first three computers is sales. The last three computers, HR department. Let me keep one piece is admin. This is VLAN. So let me make VLAN 10 here, VLAN 20 here. Show VLAN brief. VLAN 1 is a default VLAN. Again, 1002 is default VLAN, 1003 is default VLAN. So we don't use these VLANs actually. It's outdated technologies. VLAN 1. So by default, how many VLANs is there in switch? By default, how many default VLANs in switch?
1.
Yes. How many default VLANs in switch?
One.
1.
5 default VLANs. 1 default VLAN. 1002 is also default. 1003 is also default. 1004, 1005 is all our default VLANs. Out of 5, management VLAN is VLAN 1. Administrative VLAN is a VLAN 1. So how many default VLANs in switch is a 5? Out of 5, VLAN 1 is a management. VLAN 1 is a administrative VLAN. So all ports the part of management VLAN, admin VLAN. Okay. One is a, 1002 is a. In between the VLANs we can create. Means VLAN 2, VLAN 3, 4, 5, up to 1001 we can create. Let me create VLANs. In global configuration mode, VLAN space 10, VLAN 10, namespace name, sales. So VLAN 10 is created. Next, VLAN space 20, namespace name, HR. So have created 2 VLANs. This is just VLANs ID is created. And we
You're
implement the
not
port.
assigning any interfaces.
Yeah, we need to implement now.
Okay.
Now we need to be add interfaces. So VLAN 10 sales is ID. Just VLANs is created. Now, what is our example? Port number 1 should part of VLAN 10. Port number 2 should part of VLAN 10. Port number 3. So let's implement these ports. First, port number 1. Interfaces means interface. Pass Ethernet 0/1. Port number 1. Switch port mode. I'm making the port number 1 is accessible. Access port. Switch port mode access. Switch port access to which VLAN? VLAN 10. So now port number 1 is a part of VLAN 10. Exit. Similarly, port number 2. Port number 2, switch port mode access. Switch port access VLAN number 10. Now port number 1, port number 2 is a part of VLAN 10. Port number 3, node access. Access VLAN 10. So like we can implement the ports, interfaces. The port number 1, port number 2, port number 3 is a part of which VLAN? VLAN 10. It's a small broadcast domain, 3 ports broadcast. Next task is what? Port number 5, port number 6, port number 7 will implement on which VLAN? VLAN 20.
VLAN 20.
Yes. So this is one type of method actually, like one by one, port number 1, port number 2, port number 3. Like when we have the multiple ports, we can use the range command also. I'm using here interface range fast Ethernet 0/5 space hyphen 7, 5 to 7, 5 to 9, 5 to 20. Like range of ports we can be implement at one single command. More access VLAN number 20. So before we have implemented single ports, each port. So now we have implemented multiple ports with a single shot using a range command. Okay. Now if we check show VLAN brief, here 1, 2, 3 is a part of sales, and 5, 6, 7 is a part of HR department. Like total, how many broadcast domains in this switch? Yes, please. How many broadcast domains? VLAN 1 is one domain, VLAN 10, VLAN 20. Number of VLANs, number of broadcast domains. So when PC1 means port number 1 traffic is generated, now broadcast to 2, 3 ports only. If traffic is coming from port number 6, now broadcast to 5 and 7 only. If broadcast is generated from port number 4, so rest of all the ports is being broadcast. So 3 different broadcast domains in the switch now. Now let me check the communication between the same VLAN, means sales to sales. I'm using the left side packet, keep packet here, source and destination. It's successful. Like 2 to 3, successful. Like 1 to 3, successful. So same VLAN's communication is okay. Now VLAN 10 to VLAN 20, different broadcast domains, VLAN 10 PC and VLAN 20, it's failed. You know why? Because broadcast will be happen only within the VLAN. See, from VLAN 10, traffic is generated. The what switch will do, send the broadcast to 2, 3 ports. That's it. So broadcast not going to other department. So this is how we can create VLANs and implement VLANs. Is clear? Any doubts? Is the configuration commands, creating VLANs and implementing of VLANs. Right. So we have seen VLANs in one switch. It's in a switch B also. Yeah, here we have two switches, switch A and switch B. In switch A, VLAN 10 are sales department and 20 is HR department, right? Now what if we have a same sales department in switch B, HR department in switch B? Then how we can allow communication switch A sales to switch B sales? Switch A HR to switch B HR. The first thing is in switch A for sales department, what is the VLAN ID we have used? VLAN number 10. In switch B also for sales department, VLAN ID should be the same. Here you have to use what? VLAN number 10. Name can be any name. Here you can use sales A, here you can use sales B. Name can be any name. VLAN ID should be same. Same like a HR department. Here you have used VLAN 20 and for HR VLAN 20 how to use to configure VLAN 20. Okay, the same VLAN IDs you have created in B. But what is the connectivities? Like how many links we didn't require? So VLAN 10, VLAN 10, one link, VLAN 20, VLAN 20, one link, VLAN 30, VLAN 30, VLAN 40, VLAN, not like that. Like multiple VLANs can follow the traffic with a single physical link. So just we make one a cross cable from switch A to switch B, uplink port. But this link by default allows VLAN 1 traffic only. Because of this link by default, the ports are access ports. Access ports are, it can be trunk ports. Two modes is there in switch ports, access mode and trunk mode. What is access mode? If port is an access mode port will allows only single VLAN traffic, VLAN 1 traffic only. When your port is in port number 24 is in access port, if access mode allows which VLAN traffic? Only VLAN 1 traffic. Here also, only VLAN 1 traffic. Then what is our requirement? VLAN 10 should communicate. VLAN 20 communicate. VLAN 30, VLAN 40 like this. So when your port number 24 allows multiple VLAN traffic keys, now we need to be configure trunk. So we configure trunk ports. So trunk port allows multiple VLAN traffic. Now how exactly trunk allows multiple VLAN traffic is? You can read this point, trunk. Trunk port allows multiple VLAN traffic to pass through a single physical connection. Trunk port allows multiple VLAN traffic to pass through a single physical connection. How? By adding a header. What we call this process? Adding a header. This process what we call it?
Encapsulation.
Encapsulation. Very good. So here we have to discuss about trunk encapsulation. So trunk encapsulation protocols are two protocols. One is ISL, inter-switch link. One more is 802.1q. What's the difference between 802.1q and ISL? So ISL is a Cisco protocol, Cisco proprietary. .1q is a open standard protocol. So what these protocols will do? Encapsulation. Encapsulation means what? Adding header. So this header size for ISL is a 30 bytes of header size. If it's .1q, very simple header, 4 bytes of headers will use it. If header is simple, then fast communication. And moreover, it's open standard also. It can support for multiple vendors. So that is why even Cisco switches also by default using 802.1q protocol only. So trunk encapsulation methods are two different types, ISL and .1q, which is inter-switch link, 30 bytes of headers and trailer. .1q is what? Open standard, 4 bytes of headers. But how this exactly this trunk protocol will works is how it's allowing the multiple VLAN traffic means. Let's example port number 24. Port number 24, if it is a access port, when VLAN 1 user traffic is coming, what access port will do is allow you because of VLAN 1 traffic. Means by default this link allows VLAN 1 traffic. But when VLAN 10 traffic is communicating, when VLAN 10 traffic is coming, if port number 24 is a access, then what port number 24 will do? Drop it. Why? Access port allows only VLAN 1 traffic. Then how we can allow multiple VLAN traffic? Now to configure trunk. So enable trunk on port number 24. So if we configure trunk, then which protocol will come in the picture? .1q. Open standard protocol. So now if we see VLAN 10 user is communicating with switch B VLAN 10. Data traffic is being received. Now what switch will do? It's adding headers. So that headers we called tags. It's adding a tag. Generally, what is the purpose of tag? What's the purpose of tags? Identification, right? Tag is for identification. So inside the tag, VLAN ID will be there. So data is belongs to which VLAN ID? It's VLAN 10. So your tag is added, adding here. Now data plus VLAN 10 means tag. Both is being forwarded to switch B. Now what if switch B is an access port? Drop it. Now switch B also need to be configured trunk here. So if we configure trunk and switch B port number 24, what trunk will do? It'll open the tag. So based upon the tag information, B24 can come to know data is belongs to which VLAN. So now here open the tag and based upon the tag information, it knows that and tag is being removed. Tag is removed. Data is being sent to VLAN 10. So this method we call VLAN tagging method. So when tag is adding, when tag is removing, when data will come to trunk port, tag is added. When data is leaving the trunk port, tag is removed. So the tags will be only trunk links, not end users. End user will send data, end user will receive the data. So only the link will be carry the tag. See now switch A and B users are communicating the only VLAN 1. Means this link is carrying only VLAN 1. Tags are required? Trunk is required? No. When tagging method is required, I mean when trunk is required, when the link is carrying more than one VLAN traffic, then trunk is required. If it is only default VLAN 1, then trunk is not required actually. I can read these points. VLAN tagging is used when a link needs to carry traffic for more than one VLAN. Each frame has a tag that specifies the VLANs it belongs to. Your tag will specify the VLANs which belongs to. Tag is added to the frame when it goes on the trunk, and tag is removed when it leaves the trunk. So switch forward the frames to the particular VLAN based on what? Based upon tag information. Okay. So to allow multiple VLAN traffic in the different switches, we need to be configure trunk encapsulation method. So in the real time, if you want to allow switch A department to switch B same department, C same department, between all the switches, we need to configure what? Trunk. And this is how trunk will works. So let me design the same topology. Taking a switch B, 1, 2, 3, sales, admin, 5, 6, 7, HR. So port number 1, 2, 3, 4, 5, 6, 7 ports. And IP addresses for computers 192.168.20.11. Second computer, computer 3, (14), 15, 16, and 17. Right. Now let me create VLANs in switch B also. Config mode, host name, switch B, interface VLAN 1. What is switch A IP address? 20.50, right? I'm using 51. Okay, VLAN 1 IP is assigned. Now let me create the VLANs. By default, show VLAN brief. So VLAN 1 is there. Management VLAN, all ports in the part of that. Let me create now VLANs. VLAN 10, name, sales. VLAN 20, name, HR. Now port implementations. Interface range command I'm using here. So fast Ethernet 0/1 space -3. Switch port mode access. Switch port access VLAN number 10. Port number 5, 7. Mode access VLAN number 20. My God. Sorry. Yeah. Like this, we have created and implemented VLANs in switch B. That our main target is what? Switch A VLAN users and B VLAN users have to be communicated. Means sales to sales. A sales, B sales. A HR, B HR. What will we do now? So first I'm making a one link between switch A to switch B. Cross cable. From which port to which port you have to connect? Any port to any port. So my example, port number 20 on A, port number 20 on B. So 20 to 20 have connected. 20. Port number 20 on A, port number 20 on B. Now if we check communication from VLAN 10 to VLAN 10, So this link allows the VLAN 10 traffic by default? No. Then which VLAN traffic this link allows by default?
VLAN 1.
So means let me check communication with a PC4 to PC4 here, the middle one PCs. Because of this is the VLAN one, right? Let me check. Source and destination. It's a successful. But now when you communicate with a VLAN 10 to VLAN 10, it's failed. VLAN 20 to VLAN 20, it's failed. Why? Because of this link will not allow the multiple VLAN traffic by default. Then when this link allows the multiple VLAN traffic,
Strong.
going to be configured trunk on which port number? So we have connected here port number 20 on A, port number 20 on B. Let me configure trunk. In switch A, config mode, interface, fast Ethernet, 0/port number 20, switch port mode. Which port need to configure now?
Trunk.
Switch port mode trunk, enter. Now port number 20, trunk is enabled. But we can allow the VLANs also. Switch port trunk allowed VLAN
One.
if I use 10 command. If I use 10, then port number 20 allows only VLAN 10 traffic, no other VLANs, no VLAN 1, no 20, no 30, no 40, nothing. So forcefully we are allowing port number 20 only for VLAN 10. So if your requirement is that, then we can do. Means port number 20 is trunking, but which VLAN traffic has to be allowed, that also we can define. So if is here 20, then port number 20 allows which VLAN traffic? Only 20, no other VLANs. Okay. Or if we use all command, then all VLANs, VLAN 1, VLAN 10, VLAN 20, all VLANs has been allowed. Right. So repeat the configuration. Interface port number 20, switch port mode trunk, switch port trunk allowed, VLAN all. Same configuration in switch B also. In switch B, interface fast Ethernet 0/port number 20, switch port mode trunk, switch port trunk allowed, VLAN all. Now verification, show interface trunk. Please show interface trunk command. Now can get port number 20, mode is on, encapsulation is .1Q, status is what? Status is trunking, and VLANs are allowed. VLAN 1 is allowed, 10 is allowed, 20 is allowed. Now if we check between the V10 to V10 communication, successful. V1 communication, successful. V20 successful. So this link we call this now trunk link. It's carrying the multiple VLAN traffic by single physical cable by adding headers to Ethernet frames. Tagging methods. Based upon the tags, it can be differentiated. It's clear? This is a trunk configuration. Right. Have a two switches, switch A and B. In switch A, all ports are in default VLAN 1, no other VLANs. Even the switch B also, all are in default VLAN 1. Then how to allow communication from switch A to switch B? In A VLAN 1, B VLAN 1, that's it. So how to allow communication from A to B? What we need to do?
Just connect the cable between any port.
Just to connect a cable between from any port to any port, right? So do you need a trunk here?
Oh,
Trunk is not required. Why? Because default VLAN 1. So default this link will allow VLAN 1 traffic. Then when trunk is required? If you have the more than VLAN 1 traffic, then will trunks are required, right? So example
Multiple
now,
VLANs.
yeah. Now in switch A, you have VLAN 10 users, VLAN 20 users, and VLAN 30 users. And here also VLAN 10 and VLAN 20 and VLAN 30. Then how can allow VLAN 10, VLAN 10, 20, 20, 30, 30 communication? What we need to do?
encapsulation.
Okay.
Configure trunk. Where will to configure trunk? On which port it will be configure trunk?
24
On which switch?
switches.
Switch A port number 24 need to be configured trunk, and
Switch B.
switch B port number 24 need to be configured trunk, right? Yes.
Yeah.
The main point is here, if switch A is a Cisco switch, if B also Cisco switch, both are Cisco switches. One side, if we configure trunk, then other side automatically trunk will be formed. So both sides need to be configured trunk in Cisco devices. Only for Cisco devices, both sides need to be configured trunk. One side if we configure trunk, other side automatically trunk will be formed, because of in all Cisco switches, one protocol is enabled, which is DTP, dynamic trunking protocol. So because of dynamic trunking protocol, it is going to responsibility of auto negotiations between the switches to form a trunk. DTP will take care about that. One side if you configure trunk, other side automatically trunk will be formed because of DTP is enabled. So trunk we have discussed, that is normal trunk, but this is dynamic trunking protocol. How dynamic trunking protocol works is DTP, dynamic trunking protocol. DTP is a Cisco proprietary protocol. It is responsible for what? Dynamically negotiates trunk between the switches. DTP is what? Send the negotiation messages to form a trunk. And is enabled by default. DTP is enabled by default in all Cisco switches. And it has the two modes, dynamic desirable and dynamic auto. What is dynamic desirable? Let's see the modes of dynamic DTP. See, we have connected a link. Switch A, switch B, switch A and switch B. Switch A port number 24, switch B port number 24 are connected, right? Example, switch A port number 24 is access port. Now port number 824 always act as access port, which is a non-trunk. So port number 24 always allow only VLAN 1 traffic. No other VLANs. When if is access. Next point, if 824 if is a trunk, port number 824 if it is a trunk, you have configured trunk manually. Then always act as a trunk, means always allows the multiple VLAN traffic. The next point is, if we configure 824 is a dynamic desirable mode, which is DTP, dynamic desirable, then you know what dynamic desirable will do? It's actively initiate the negotiation messages. So whenever we configure dynamic desirable, now 824 will send negotiation messages actively to other port. You form a trunk, I'm a desirable, so you form a trunk is initiating the negotiations. Not only initiating, it can be respond to negotiation messages to start using trunk. Means other side switch is configured, it can be respond, it can be initiate, it can be respond also. Okay. Then what dynamic auto will do? It's passively waiting to receive the trunk negotiation messages. Passively waiting to receive. So by default, all Cisco ports, dynamic auto, this also dynamic auto mode. So what dynamic auto mode will do is passively waiting to receive the trunk negotiation messages. Which one? A24. B24. So B24 is also passively waiting. Then which switch will initiate the negotiation message? There is no switch, there is no port. That is why by default this link is a access link. It allows only VLAN 1 traffic. Then what we'll do, either in switch 24 or B24 one side, if we configure desirable, what dynamic desirable will do, actively initiate the negotiation messages, and what dynamic auto will do is passively waiting. Whenever it initiate, then a link will be formed trunk automatically. So one side is enough. I'll show the practical. Now this link is already trunk. So let me remove this link. I'm making use one new connection from port number 15 to port number 16, 15 and 16. Port number 15 and port number 16. What is the default mode of port number 15? Dynamic auto. Port number 16, dynamic auto, right? If both are dynamic autos, auto mode, dynamic auto mode, then the link is a trunk link or access link. If both are dynamic auto, so link is what, which link? Trunk link or access link? Access, because of his waiting is also waiting, no negotiations. Then what I'm doing is, even you can check here, VLAN 10, VLAN 10, it's a failed. VLAN 20, VLAN 20 is failed. But VLAN 1 and VLAN 1 can communicate. Access link. Now any one side, either A or B, in A, which port number you have connected? Port number 15, right? Yes. Show interface trunk. We don't have a trunk now. So interface fast Ethernet 0/ port number 15, switch port mode dynamic desirable. If we use this command, switch port mode dynamic desirable, enter. That's it. So 15 is actively initiating the negotiation messages because of its dynamic desirable. Other side switch is responding. It's waiting, passive is waiting, right? It'll form the trunk now. Let me check the status, show interface trunk. Mode is desirable, status is trunking, and all VLANs has been allowed. In switch B, if we check the status, show interface trunk. What is the mode? Auto, dynamic auto. Status is trunking. So now the link allows multiple VLAN traffic. VLAN 10, VLAN 10 successed. VLAN 20, VLAN 20 successed. And VLAN 1 is also successed. So this is how dynamic trunking protocol works. DTP, just a small feature in Cisco switches. Okay. Yeah. So it's all about for today. VLANs, trunking, and dynamic trunking. The next Monday we'll continue with some advanced LAN protocols. Thank you. Have a nice day.